Here's example 3 of solving trig equations. So here we have sine of theta equals negative 0.71, and same instructions as before. We want to solve in this interval 0 to 2 pi, and all that means is 0 is less than or equal to theta is strictly less than 2 pi. And then part B, find the general solutions. Okay. So what's a little bit different here now is we have sine of theta equals a negative number. So we're going to start it the same way as example 2. First we're going to draw a unit circle, and then eventually we want to use the symmetry properties. Okay, so x-axis, y-axis, we'll put our unit circle here. Okay, so if the sine function is negative, then that means the corresponding angle theta is somewhere in quadrant 3 or quadrant 4. Okay, so remember that. So here somewhere in quadrant 3, or here in quadrant 4. And again, this y-coordinate and this y-coordinate, they're both the same. They're both negative 0.71. Didn't really draw this so well, but the y-coordinate here is the same as the y-coordinate here. So that's those symmetry properties. Because remember, if you have an angle theta that hits the unit circle at some point, then the y-coordinate at that point is the sine of the angle theta. Okay. And here's sine of theta is negative 0.71. These two angles that we drew, they solve this equation, so the y-coordinate here and the y-coordinate here are the same. Okay, so if we proceed like we did before, so if we have sine of theta equals negative 0.71, then if we say theta equals the inverse sine of negative 0.71, that's not going to give us exactly what we want, and why not? Well, first of all, if we take the inverse sine of something negative, that puts us in quadrant 4, which is where we want to be for one of the angles. But remember, if you take the inverse sine of something negative, you get something negative. Okay, so remember the inverse sine function, when you evaluate the inverse sine function, you get something between negative pi over 2, okay, negative pi over 2 and positive pi over 2. So actually, this angle right here, this right here is the inverse sine of negative 0.71. Okay, but this exact angle, let's zoom in on this a little bit. This exact angle right here is not what we want. Okay, why is that not what we want? Because our answers for part A have to be between 0 and 2 pi like this. Okay, but this here is some negative number. Okay, it's some negative number, so it's going to be not between 0 and 2 pi, so it's not what we want. So how do we fix that? Well, what we can do is just take this angle and then add 2 pi. Okay, so if we take the inverse sine of negative 0.71, and then add 2 pi, then that's going to put us, so inverse sine of negative 0.71 puts us at this angle right here, okay? And then if we add 2 pi, we're going to go all the way around the unit circle, and then we're going to be exactly at this angle that we want, okay? Exactly at this angle that we want. Which, you know, we were at the same terminal side before, but it wasn't the exact angle because this angle, again, is not between 0 and 2 pi. But this one, the one we want, is, okay? So really specifically, it's this one here, okay? So then what we can do is just say, okay, that's our answer then. That's one of our answers for part A. Okay, so theta equals the inverse sine of 0.71, or negative, rather, negative 0.71, and then plus 2 pi. And we'll toss that to a calculator a little bit later. Okay. And again, we have to add 2 pi so that we can make sure that we're in this interval here. Okay. Okay, now what about this angle? So that takes care of this angle here. What about this one here? So now this is when the symmetry properties come into play. So the same exact reasoning with example 2. Since this y-coordinate, or since the y-coordinate here and the y-coordinate here are exactly the same, then this angle here and this angle here have to be the same angle, okay? And we already know this angle here is the inverse sine of negative 0.71. Okay, we already know that. Okay, now that means this angle here has to be exactly the same thing. Okay, so this one right here is also the inverse sine of negative 0.71. Okay. Okay, now how does that help us? Well, if we start here at this positive x-axis with an angle of 0, go around here, that's pi. Okay, that's going to be pi. Now, what if we continue on down here? Then that's going to put us at the angle we want, but what do? We went this inverse sine of negative 0.71, but we did it in the opposite direction, okay? So inverse sine of negative 0.71 goes like this, right? In the clockwise, the negative direction, because it is a negative number. Okay, if you toss this into a calculator, you get a negative number back, and we'll see that shortly. But since inverse sine of negative 0.71 is a negative number, then that corresponds to this negative angle here. Okay, this theta is negative. It's a negative angle. So that's why it opens in the clockwise direction, the negative direction. Same thing over here. Okay. So this angle and this angle are exactly the same. So this angle here is exactly the same as this angle, but it goes in the opposite direction. Okay, so they're the same size, but they're just negatives of each other. Okay, these two angles here are negatives of each other. So if this one is positive sine of negative 0.71, then, or sorry, positive inverse sine of negative 0.71, then this angle is the negative inverse sine of negative 0.71. So if we take pi, okay, if we go around pi, like here, and then add to that this angle, which is negative inverse sine of negative 0.71, then that's going to give us what we want. Okay, that is this angle. Let's call this angle theta 2. Okay, so this angle is going to be theta 2. Okay, equals theta sub 2, we'll call it. Okay. Okay, so again, if we start here at this angle of 0, go around pi, it's going to put us here, and then add this angle here, which is negative inverse sine of negative 0.71, then that's going to give us this angle here that we want, which again, we just call that theta sub 2, theta with a subscript of 2. Okay, so go around pi, and then add negative inverse sine of negative 0.71, that's what we get. Okay, so in other words, theta sub 2 equals pi minus, the inverse sine of negative 0.71. Okay, so here pi plus negative blah blah blah, so plus negative means minus, so pi minus the inverse sine of that. Okay, okay, so these are our two answers then. Inverse sines, we kind of erase this one here. Inverse sine of negative 0.71 plus 2 pi is one of our answers. And the other one is just pi minus the inverse sine of negative 0.71. So let's turn to our calculator and see what those answers are, approximately. So again, make sure that we're in the radian mode, and make sure that we actually do inverse trig and not just regular trig. So inverse sine of negative 0.71, then we have to add 2 pi to that. Okay. And the other thing we wanted was pi minus the inverse sine of negative 0.71. So our answers are approximately 3.9311 and approximately 5.4937, we'll say. Okay. So let's go ahead and write those down. So for part A, the answers then are theta is approximately 3.9311, or theta is approximately 5.4937, we said. Okay, and that's it for part A. Now, how about part B? Part B, find the general solution. So just like in the previous examples, all we do is we just take these and we add the 2k pi. Like we've been doing, we explained it in the previous example, so we don't want to cover it too much again here. Anyway, just say theta is approximately equal to, because these are approximations, so approximately 3.9311 plus 2k pi, where k is any integer, abbreviate int for short, we're out of space, or theta is approximately equal to 5.4937 plus 2k pi, where k is any integer. And that's our answer for part B. And that's it for example 3 of solving trig equations.